Okay, in this video, I'm going to show you how to do the post hoc comparisons. Post hoc meaning after the fact. If you recall with a one-way ANOVA, when we run the omnibus test, that just tells us that one group, at least one group, is different from the rest, but we don't know which. The post hoc tells us which. Um, Later, we'll do planned comparisons where we want to know specifically is this group different from that group. This post hoc compares all groups, so it kind of reduces our power a little bit. We're not fishing here, but we're looking at everything. We don't have a specific plan in mind. Um, Before we start, as usual, I always like to look at the error bars because when we look at the 95% confidence interval with our value in our groups, this can usually give us an idea of what our results are going to look like. So if we look at A and B, those are really close. If the confidence intervals don't overlap, then they're probably significant. They're probably a big difference. So if we look at B and C, those are clearly overlapping, so they're probably not going to be different. A and B can't really tell, and that's why we still need to run the test because this is close. D is going to be significant. Yeah, we can tell that. I know that because I simulated the data, but um, we can also see that from the graph here. This is the same data as before with just random values and some groups. So when we run our one-way ANOVA, just like we usually do, these post hocs are going to go along when we run the overall ANOVA, so it all happens at once. We have a lot of options here. There are a group of post hocs for equal variances assumed. Equal variances not assumed. These are what we would use if we didn't have equal variances, but we do. I know they're exactly the same. We would test for that, but I know that they're the same. Normally, we wouldn't run all of them. We'd run one, and all of these different post hocs have different benefits, different penalties that will influence our power and our ability to see significance. Our goal, however, is not to just find which one will give us significance. We're looking for a more appropriate test. We're not going to go through every one of these post hocs. Usually what you'll see is a Tukey or Bonferroni, LSD. Those are, I think, probably the more common ones. Again, you'd only run one, but I'm going to run all of them. You don't want to run all of them, but I'm going to run all of them so we can compare and see some of the difference between these. That's it. That's in post hocs. Everything's set at the same. Options. We'll look at the homogeneity of variance tests. And we've already looked at the mean plots, so that's good. And we'll do contrast later. There we go. Here's our ANOVA. Homogeneity of variances. Yes, we can assume that they all have the same variance. That's around there. There's our overall test. So at least one group is significantly different than the rest. We have our effect sizes, and now here we have our post hocs. So normally if you just run this, you'll just have one of these, but since we ran all three to compare, we have a much bigger table. This table will compare every group with every other group. So we see group I and J. This is looking at group A compared to group B, group A compared to group C, etc., etc. So these will be duplicates as we go down here. You can see group A and B, the mean difference. So the difference between the mean of A and the mean of B, I minus J, is negative 2.5. If we go down here to B, look at A, we see it's the same thing with sign inverted. So there's duplicate data in the table, but that's just what it is. When we looked at that plot before, we saw that A and B look like it might be significantly different. We couldn't really tell. And if we look here, we can see 0.015 for significance. So yeah, it is significantly different, just barely, but it's there. If we look at A and C, big peak value. So we're not significant here, and 0 is within the confidence interval, so we also know that. And A and D is the one that's very different from all the rest, so yeah, very significant. 0 is way out of the confidence interval, so we know that one is different. Now, let's just look at A. Let's look at the A and B, because that is very close. And with Tukey, HSD, it is significantly different. But at 0.01, if we look at the LSD, A and B, it's still significantly different, but it's at 0.003. So LSD is saying that it is more different. And then Bonferroni is very close. So that's the difference that we're looking at with these different tests, the difference in power that they have, and the width of, we can see here, 4 to negative 0.8. Where'd it go? Negative 4, negative 0.8, negative 4. You can see that the width of the confidence intervals will change between the different tests. So again, we're not checking all these to find which one is significant. We have specific reasons why we might choose one or the other, and we'll go over those later. But that's the difference between the post hocs done after the fact. Then the subsets, this is doing the subset for just the Tukey. This will compare kind of the groups, so we can see A and C. There's not a significant difference between them, so they're kind of in a group there together, maybe. And then with C and B, they're almost significant, but they're close. And then D is very different. So this gives us a way to kind of see where maybe groups overlap or groups might be related to one another. And that's it. Those are our post hoc tests. We looked at our mean plots. We saw which ones probably were. And then we ran the overall test and looked at the post hocs, and we confirmed what we suspected when we looked at the plot at the start. And that's it. Those are post hocs.